which equation has the same solution as x squared minus 6x minus 12 equals 0? And then there are 4 different answer choices here, all different equations. So the goal of this problem is to figure out which of these 4 equations has the same solution as this equation. So we need to solve this equation, find the solutions, and then figure out which of these have the same solution. Well, if we look at our equation, x squared minus 6x minus 12 equals 0, the first thing you might notice about this is that it is a quadratic equation because of the x squared term. And there are a lot of different ways to solve a quadratic. You could use quadratic formula, you could try to factor it, you could solve by completing the square, and you could pick your favorite method and try at it right now. But in this case, the answer choices give us a clue as to which approach might get us the answer the fastest. So if you look at your 4 answer choices, they're all in the same form. They're in the form x plus or minus some constant, quantity squared is equal to some constant. And that right there is a step in the completing the square process. So if we were to, and you can approach this in a lot of different ways, but if we were to complete the square, or if we were to solve by completing the square, then we could get to a step that gives us this. So we're going to go ahead and try that. We're going to solve by completing the square. So if you recall, when you're completing the square, the first thing to do is to move the constant onto the other side. So we're going to do that by adding 12 to both sides of the equation. And so negative 12 plus 12, that becomes 0. So we'll just leave it here. 0 plus 12 is 12. Okay? Now we take the coefficient of x, which is negative 6, and we divide that by 2 to give us negative 3. All right? And then we have to square this guy. So negative 3 squared is equal to positive 9. All right? So what we now do is we take the positive 9, and we are going to put a positive 9, or in other words, add 9 to both sides of the equation to keep it balanced. So we're adding 9 to the left side, and we're adding 9 to the right side. And now this trinomial on the left side of the equation is a factorable trinomial. And this guy is going to be x minus 3 times x minus 3. And if you notice, the minus 3 and the minus 3, there's nothing surprising here, because this minus 3, this negative 3 that we found up here, is going to be the same as these things. So that's always one way to remember. The number you got when you divided the coefficient of x by 2, that's the number that's going to appear twice in your factors. And then equals, and then 12 plus 9 is 21. And if we look at our left side, we have 2 sets of parentheses with x minus 3 in them, which is the same thing as x minus 3 times itself, or just squared, which is equal to 21. Now, we could then continue to solve and take the square roots of both sides, la-di-da. But if we stop here, we say, hey, wait a second. This guy right here matches this guy right here. So lo and behold, we don't actually have to find the solutions. We can stop right there and say, well, we have found our answer. It's answer choice number 2. So that's the quickest way to approach this, is by recognizing that the answer choices are steps in the completing the square process, and then to solve this equation by completing the square. And if you like that approach, it makes sense to you, and you understand the answer, then go ahead and stop the video. If you want to see another method, stick around. All right, so to take a look at this in another way, we're going to clear our frame, and we're going to start back over. And let's say you didn't recognize that these 4 answer choices were steps in the completing the square process, and you were just trying to do this some other way. Well, you can still do it another way. So one way you could do this is by actually solving this equation using whatever method you know how to use, and then figuring out which of these has the same answer or the same solution. So let's do that a different way. So let's take this guy, and let's say you want to use the quadratic formula. So in order to use the quadratic formula, we need to know the a value, and a is the number in the coefficient of x squared. And since we don't see anything in front of x squared, we know We know that that's actually a 1 there, so the a value is 1. We know the b value is the coefficient of x, and x is here, and I see a -6, which we say is a -6 for the b value. And we know c is the constant. You can always remember c for constant. And the constant is the value that doesn't have an x attached to it, or is not a coefficient, but is a constant. So that is going to be the -12 or the -12. So our constant is -12. The c value is -12. So we use our quadratic formula, which we know is x equals -b plus or minus the square root of b squared minus 4ac, all divided by 2a. And if you're sitting there trying to remember the quadratic formula and you just can't quite remember it, remember that you can always go to your formula sheet, which they give you on the Regents exam. And sure enough, right here, you don't ever have to remember it all the way through. It's good to remember it, but if you forget it on the day of the exam, you can go to your reference sheet and pull it right out. Okay, so don't freak out if you forget it. But here we go. So here's our quadratic formula, and let's substitute to solve. And we'll do that by x equals -b. So negative and b is -6. So I'll replace b with its value, -6, plus or minus the square root of b squared, or -6 squared. Notice every time I substitute, I use parentheses. The a value is 1, and c, which is -12, times c, all divided by 2a. So we can say that x equals the -6, or the opposite of -6, which we know is just 6, +6, plus or minus the square root of -6 squared is -6 times itself, or -6 times -6, which is +36. And then we have this this product here. We have a -4, a 1, and a -12, and we're multiplying those all together. So it's -4 times 1 times -12, which is -4 times 1 is -4 times -12 is +48. And that's all divided by 2 times a, which is 1. Okay, and then, I don't like how, I wrote that a little big. Okay. Okay, so we have x is equal to 6 plus or minus the square root of 36 plus 48 is 84, divided by 2 times 1, which is 2. And we can stop there for now. We may have to simplify this further or do something with our calculator, but this is our solution. So this is the solution, or the solutions. We have two solutions here because it's 6 plus square root of 84 over 2 and 6 minus square root of 84 over 2. So we have two solutions to this quadratic equation. So the question then becomes, which of these four equations has the same solution as this guy? Or in other words, which of these four equations has this as its solutions, as its solution set? And, at this point, you can literally just, go one at a time. But let's take advantage of the fact that each of these four answer choices are written in a form that doesn't require a lot of steps to get to the answer or get to the solution. So let's look at answer choice number 1. We know that x plus 3 squared is equal to 21. Even if you had forgotten that this was part of completing the square, if you notice, we have something squared is equal to a constant. So when you're trying to solve an equation, something squared is equal to something else, the easiest way is to get rid of the square first, and we do that by taking the square root. But we got to be careful when we take the square root of something squared, because if you recall, a positive number squared is equal to a positive number, and a negative number squared is equal to a positive number. So the solution here, so this side could actually be positive or negative. So we account for that by doing plus or minus the square root of 21. So whenever you're solving something like this, and you're taking the square root of something squared, don't forget the plus or minus. And we could say the square root, cancels out the square here, and we're left with x plus 3 is equal to plus or minus the square root of 21. And then we could subtract 3 on both sides. And we have x is equal to, so we subtract 3. Let's just put it in front here, so it's essentially 0 minus 3. And we'll get negative 3 plus or minus the square root of 21. And I put it there in front because it matches the way we structured the answer up here. So we look at this and we look at this and we say, these don't look the same necessarily, but we're not sure because we still have this 2 on the bottom. So we kind of have to either simplify this further or type it into a calculator and see. So we're going to take a look at both of those methods. The first involving trying to break this down a little bit further. And then we're going to take we'll look at the other way, which involves just typing this into a calculator and comparing it. So the first way is, well, recognizing that since this answer choice doesn't really look like this answer choice, that's kind of a hint that maybe this square root of 84 could possibly be simplified a little bit further. And if you recall, the way that is done is, let's take this expression 6 plus or minus square root 84. The goal here when breaking down or simplifying a radical is to find the greatest perfect square that goes into 84. So what are our perfect squares? 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, and 7 squared is 49. And I'm going to stop there because 49 is more than half of 84. And as soon as I hit more than half, I know that no numbers bigger than 49 could possibly go into 84. So I'm going to work backwards and see which number goes into 84 or divides evenly into 84. 49 is too big. It's more than half 84, so I know 49 doesn't go in there. But 84 divided by 36. Does 36 divide into 84 evenly? No. How about 25? No. Does 16 go into 84 evenly? No. How about 9? 84 divided by 9? Nope. How about 84 divided by 4? Yeah, that actually works out. 84 divided by 4 gives me an integer, 21. So 4 is the greatest perfect square factor of 84. If 4 hadn't worked, then 1 would have been, and this wouldn't have gone any further. But since 4 is, we're gonna simplify this up further by doing square root of 4 and square root of 21. Perfect square factor we put first, and 4 times the 21 gives me the 84. Put that over the 2, and then we have square root of 4, which we know is just 2. So 6 plus or minus 2, square root of 21, divided by 2. All right, and so this simplifies down further because we have 2 terms here, and both are even. So we can divide both by this denominator. So 6 divided by 2 is 3, and plus or minus, and then 2 divided by 2 is just 1, or we just write the radical 21. All right, and then 21, we know since we found the greatest perfect square factor up here, that 21 is already in most simplified form. So we have taken our x equals 6 plus or minus the square root of 84 divided by 2 and simplified it to 3 plus or minus square root of 21. And if you're ever in doubt, if you have simplified it correctly, you can always check. Let's go to our trusty calculator and let's check. Let's do just the 6 plus. 6 plus square root of 84. And let's just hit enter and then divide this answer by 2. And we get 7.582. And then let's do 3, and let's just do the plus, and let's do square root of 21. Let's just make sure that these are equivalent. They better be, or we did something wrong. Okay, good, we're fine. And then the minus 1 would work as well. So basically what we're saying now is the solution to this equation is 3 plus or minus, x equals 3 plus or minus the square root of 21. So going back to our original point is that we're trying to figure out which of these 4 equations have this as a solution. Well, if we look at our first answer choice, x equals negative 3 plus or minus square root of 21, that's pretty close, but this has the negative in front. So this solution does not match this solution exactly. So this equation does not have the same solution as this equation does. So 1 does not work. At this point, the strategy is just to work through each one, doing a very similar process, and seeing which one gives us this solution. So if we proceed to number 2, I'll do that one in brown. We'll have x minus 3 squared is equal to 21. Again, we'll take the square root of both sides and the plus or minus square root of the other side. And then the square and the square root cancel out, and we get x minus 3 is equal to plus or minus square root of 21. And then in this case, we'll add 3 to both sides, and I'll put the 3 in front. And that gives us x equals, and then positive 3, or just 3, plus or minus the square root of 21. Boom, look at that. So sure enough, the answer choice that we got by completing the square in the last strategy is the same answer choice, it better be, that we get using this strategy. Now, if you look at, there's a lot more here, but it gets you the right answer as a different way to approach it. So overall, when we get to answer choice 2, we solve it, we get the same answer or the same solution as the original one when using the quadratic formula. So you might be thinking, well, what if I had forgotten how to simplify radicals? Well, you've always got your technology here. So just like we did before, if you weren't sure that how to break down the 84, you could just have stopped here and stayed with 7.582. So just make a quick note of that off to the side. We know that this is approximately 7.582. The positive solution is when we do the plus, we get 7.582. So if you just make a quick note of that, write that decimal down somewhere. When you get to each answer choice, just type in the positive root and just see which one gives you 7.582. So if we were to test again the first answer choice, we have -3 plus square root of 21. Does this give us 7.582? No, it gives us 1.582. When we get to answer choice 2, 3 plus the square root of 21, well, we already know what that is. It's 7.582. So you actually could have proceeded with this using technology rather than actually going through the simplification step. But we reviewed that as well, because if this were a short answer problem, you may have to simplify, you may have to show your answer in simplified radical form. So you want to remember how to do that as well. When solving the equation 4 times the quantity 3x squared plus 2 minus 9 is equal to 8x squared plus 7, Emily wrote 4 times the quantity 3x squared plus 2 equals 8x squared plus 16 as her first step. Which property justifies Emily's first step? And then there are 4 properties here. So the idea is to figure out which property, which of these 4 allowed us to go from 4, and I'm going to write them over here so we can look at them one after the other, to go from this equation, 8x squared plus 7, this equation here, to this equation here. So I'm going to write that one right underneath it so we can compare them side by side. Equals 8x squared plus 16. Okay, so there's some property that allows us to take this equation and go to this equation. And it's going to be one of these 4. So let's do a quick review of each of these 4 properties. So the first one, the addition property of equality. So right away you're thinking, well, addition, that's probably to add, and equality, oftentimes we think of that as equals or an equation. This allows you to take an equation such as x minus 7 is equal to 10 and add both sides to the equation, addition property of equality. So the first step here to solve this equation, we would add 7 to both sides of the equal sign. And that would, minus 7 plus 7 becomes 0, and we have x equals 10 plus 7 is 17. So this idea of adding one thing to one side and the same thing to the other side is allowable by the addition property of equality. That says that this equation is equal to this equation. So that's the addition property of equality. That's answer choice 1. Then we have the commutative. Then we have the commutative property of addition. So that says that if you have any equation or expression, so let's just take an expression like 2x plus 5. When you have the idea of addition, when you're adding two things, you can add them in any order. So 2x plus 5 is the same thing as 5 plus 2x. Similarly, adding two numbers like 9 plus 17 is the same thing as 17 plus 9. And if you look, 26 and 26. Or if you have, x plus 3y and 3y plus x, you can add. You'll get this. This represents the same quantity. So you can rearrange the order of adding, and that's allowable by the commutative property of addition. Number 3 is the multiplication property of equality. So you might see some similarity between number 1 and 3. This is the addition property of equality. Number 3 is the multiplication property of equality. So there's a relationship here. There's similarity. So as in number 1 that allowed you to add both sides to the equation, number 3, multiplication property of equality, allows you to multiply both sides of the equation. So let's set up an equation like x divided by 7 is equal to 10. So an equation like this where we have division, you might think, well, the way we could solve that would be to multiply both sides by 7. And when you do that, you get 7x over 7, which just simplifies to x, or 1x. and this gives you 10 times 7 is 70. So this step here, when you're multiplying each side of the equation by the same number, is permissible by the multiplication property of equality. And then number 4, the distributive property of multiplication over addition. So the distributive property, if you recall, that involves taking some quantity on the outside of parentheses, like maybe 10, and then something inside the parentheses, another quantity, and we're going to be adding them together. So something maybe like 10 plus 17. And the distributive property of multiplication says that this expression here is going to be the same thing as the expression if you multiply or distribute this guy outside to each thing inside. So 10 times x is 10x, and 10 times 17 is 170, with the addition in the middle. So this expression and this expression are equivalent, and that's the case because of the distributive property of multiplication over addition. So we have 4 different properties here, and we got to go back to our original question, which is which property takes us from this equation down to this equation. So let's compare. We have this equation here, and it looks like Emily may be solving this equation. Maybe not, but looks like she's definitely doing something to it. And the thing that changes is this minus 9 is no longer here, and the 7 is now a 16. So, well, what happened? Well, we know that the 7 became a 16, and that happens if you add 9 to it, and the minus 9 becomes nothing. And well, how do you get nothing from minus 9? Well, if you add 9 to minus 9, or add 9 to negative 9, you get 0. So what happened here was we added 9 to give us 0, and we don't have to write plus 0. And we also added 9 to this side to give us 16. So since we're adding 9 to the left side of the equation, and we're adding 9 to the right side of the equation, let me circle that. Since we're adding 9 to the left side of the equation, and we're adding 9 to the right side of the equation, what we're actually doing here is adding the same thing to both sides, which is allowable by the addition property of equality. So the answer is number 1. Officials in a town use a function c to analyze traffic patterns. C of n represents the rate of traffic through an intersection where n is the number of observed vehicles in a specified time interval. What would be the most appropriate domain for the function? Okay, so we're talking about this function that we call c, and it's taking the input n and producing some output. So we could say c of n is equal to whatever. And we don't know what this is over here, but we don't care about what this is over here. What we care about is the function itself. And the question here is about what is the most appropriate domain. So domain is simply the values of n that can work for this function. And you might be thinking, well, how do I know what values of n I can put into this function if I don't even know what the function is? Well, we don't have to know what the function is because we have some, we don't have like an equation here, but what we do have is what the function actually represents. It represents the rate of traffic through an intersection, and n is the number of vehicles that go through an intersection. So think about that for a second. If n here represents number of vehicles, then the question about domain is, well, what values can n take on that this function could be evaluated at? Well, if you think to yourself, well, how many vehicles could possibly have gone through that intersection? We think, well, maybe there was 1 car. Maybe there were 2 cars. Maybe there were 10 cars that go through that intersection. Maybe there were 45 cars. Maybe there were 150 cars going through that intersection. What about 7.5 cars? Could you have 7.5 cars go through? Well, no, not really. You can't really have half of a car. So this idea of n representing the number of vehicles, this sort of item here, this thing here is something that we count with whole numbers. So there's 1 vehicle, 2 vehicles, 10 vehicles, 45 vehicles, 150 vehicles, but we can't have like 7.5 vehicles. We can't have like 2.67 vehicles. We can't have, 45.721 vehicles. So we have to keep whole numbers when we're talking about vehicles, or a lot of different things can only be whole numbers. So we know that we're dealing with whole numbers here. So if we look at our answer choices, we can eliminate answer choice 3 because we know we can't have like a half of a vehicle, half of a car. That doesn't make any sense. 1.5 cars. Well, what? That doesn't make any sense. So we can eliminate the one with half. Then we have to look at our other answer choices. Well, we say, well, looking at our other answer choices, which of these have values that could potentially be numbers of vehicles? Well, I look at this one here and I say, well, -1, -2. Can you have negative number of vehicles? No, that doesn't make any sense. When we're counting something like vehicles or cars, we start at, well, what do we start at? We start at 0. There could be no cars going through the intersection. That's a valid number. So 0 could be allowed, but anything negative, that doesn't make any sense. So we wouldn't say we have -1 cars going through the intersection or -2 cars. So these we can eliminate as well because they have negative values in this set and cannot take on negative values because it represents the number of something, and this something can only be whole numbers. So we're left with answer choice number 4 as the correct option because we have whole numbers 1, 2, 3, and the ... just means 4, 5, 6, 7, 8, 9, 10, all the way up to infinity. And we could also have 0 cars. We can't have fractions, we can't have decimals, and we can't have negative cars going through the intersection. So with a problem like this, if we're talking about a function, but the variable represents something that is only countable with whole numbers, that tells you something about the domain. Well, the domain is what values that could take on. It basically tells you it has to be all whole numbers and not negatives either. Given y plus x is greater than 2 and y is less than or equal to 3x minus 2, which graph shows the solution of the given set of inequalities? Okay, so this problem is asking for us to identify which graph represents the solution of this set of inequalities. So we have 2 inequalities here, and when we're talking about the solution of a set of inequalities, this is really solving a system of inequalities. So that's the type of problem this is. So in order to solve a system, we need to graph each of the 2 inequalities on the same graph paper and find where the 2 inequalities overlap. And so the easiest way to do that is turn to the back of your Regents book and open up or rip off the scrap paper, because this is where this comes in really handy. So what we can do first is draw some grids. If you have a ruler, it's helpful, but we'll just pretend that we don't, and we'll draw an X and Y axis on our scrap paper. And I'll do the best I can. Yeah, it's good enough. Here's our x-axis, here's our y-axis. It's always nice to add our arrows, even though this is just scrap. Keep the good habits. Okay, so here's our x and our y. Now we need to graph each of these inequalities. So the first inequality, y plus x is greater than 2. Well, the easiest way to graph this inequality is to get it into similar to y slope-intercept form, where for a line it's y equals mx plus b. But similarly for an inequality, it would be y is greater than or less than or equal to mx plus b, where m is the slope and b is the y-intercept. So whenever we isolate y, it allows us to graph this much easier. So if we look at our first inequality, y plus x is greater than 2, y is not by itself, but we can get it by itself pretty quickly. So the way we can do that is y plus x is greater than 2. And to get y by itself, we can subtract x from both sides of the inequality. And when we do that, we have plus x and a negative x becomes 0, and we're left with just y on the left side of the inequality, and is greater than, and then 2 minus x. And I'm looking here, we have the 2, the constant first, the 2, and then the minus x. And, and this is fine. If you're comfortable with this, that's fine. But I like to put the x first. So I'm going to write y is greater than, and I'm going to pull the x out front. But remember the negative, the sign in front of the value, either a variable or a constant, always travels with it when we rearrange. So the negative x or the minus x, we pull that first, we have negative x. And then the 2 is positive, so we have the plus 2. Okay, so we're going to graph this inequality here. And I'll do this one in pink. So we know that the y-intercept is positive 2. So we'll go up to 2 and put our point. And the slope of this, what we think of as the boundary line, will be negative 1 or negative 1x. So when we have a slope of negative 1, we can think of that as negative 1 over 1. So the change in y is negative 1 and the change in x, rise over run, is positive 1. So when the change in y is negative, we are actually going down by 1. And when the change in x is positive, we're going to the right. So we're going down and to the right, and we'll plot a second point. And we're going down and to the right, and we'll plot a second point. And we can keep doing this to help us find our boundary line. And we'll go in both directions. Remember, if we're going down and right, it's the same as going up and left. And if you've forgotten why that is, remember negative 1 over 1 is the same as 1 over negative 1. This is the same. These are two different ways to write negative 1. So here we go. Here are some points along our boundary line. Now, if you recall, when we're dealing with inequalities, if this were an equation, we could just draw our line to represent all points on that line, all solutions to that equation. But we're dealing with an inequality, so we have to be careful when we just go to automatically connect our lines. Remember, when we have greater than, or if we have less than, without the equal sign, then what that means is the points that would be sitting on that line are not part of the solution of this inequality. So when we think, well, if we're not including the points on the line, then we can't actually draw a solid line like we're used to. So what we actually do is we draw a dotted line or a dashed line to represent that this boundary line is not, the points on this boundary line are not included in the solution set of this single inequality. So we'll just graph little dashes here. Like this. Just as long as it's not solid, you'll be okay. It can be points, it can be dashes, doesn't really matter. And don't forget to put the arrows, because this boundary line goes forever in all directions. And we are going to label our inequality. So we could either label it using this form, or we can label it using the original form. It doesn't matter because they are equivalent. So out of habit, I always like to use the original one that's given. So y plus x is greater than 2. I'm just going to write that next to the line. Y plus x is greater than 2. And you might be thinking, well, why are you doing this so carefully? Because this is just scrap paper. I know. It's a multiple choice question. But, it's, again, keeping the good habits good. Okay, so then we've now graphed the boundary line, and we have to go and graph the solution set. So when we do that, we have to think, well, we know that since this is an inequality, we're not just including points on a boundary line or not on a boundary line, but points elsewhere. So the easiest way to do this, to determine which way we are including, so we have to determine if either all the points above the boundary line up in this region, or all the points below the boundary line down in this region represent the solution set of this inequality. And so you can just pick a test point. The easiest test point to pick is 0, 0. Unless, of course, the boundary line goes right through 0, 0, then you have to pick another test point. So we'll test 0, 0. So what we're going to do is we're going to plug 0 in for y and 0 in for x. So let's plug 0 in for y is greater than negative 0, which is 0, same thing, plus 2. So 0 plus 2 is 2. 0 is greater than 2. So is 0 greater than 2? We ask that question. And the answer is no. This is false. This does not work. So because 0 is this idea here, this inequality here is not true. It is a false statement. 0 is greater than 2 is false. We can say then that 0, 0 is not part of the solution set of this inequality. And since we're dealing with either all the points down here or all the points up here, and we know this point isn't included, then we can say that it's not this set of points, but rather the set of points up on top. So it's really, the solution set includes all the points up in here, every single point. And sometimes, you're like, well, do I have to plot all the points? No. A lot of times we represent this just by using these hashes. and this is not sophisticated, this is simply meant to represent all points up here. You might have learned this as the concept of shading. Well, even though artistically you're shading, what you're really doing is representing the idea that every single point up in this area, down to the little points in between, are all solutions to this inequality. So, well, right away you might be able to eliminate a few answer choices. You could say, well, answer choice 3 here, it looks to me like there's the boundary line. So I'm just going to draw that. That one matches that one. And up here, the shading is above. Well, if I look here, I see this part is not shaded, but rather this was shaded below. So at this point, you could eliminate this answer choice here if you'd like. You could also eliminate this answer choice because the shading is also below. You actually could have eliminated this answer choice as well because you know that the boundary line is here, it's solid, but here it was dashed. So we know that we needed a dashed boundary line, and so this one was not correct. Either way, this is wrong in both counts. So 3 and 4 are not correct. So then it's down to 1 and 2. And in order to figure out which of these is the correct answer, we need to graph the other inequality. And so we have y is less than or equal to 3x minus 2. Well, if I compare the form of this inequality with y equals mx plus b, I already can see that y is already by itself on the left side of the inequality. So this one's already ready to graph as is. That's nice. So I'm going to graph this one in purple. So we have the y-intercept, in this case is -2. So we're going to start down on our y-axis, we'll start down at -2. And the slope is +3. So the slope of this inequality, or the boundary line of this inequality is +3, or +3 over 1. So the change in y over the change in x, sometimes considered rise over run. So we are rising or changing, the rate of change here is 3 over 1. So we go up from this -2, we go up 3, 1, 2, and 3, and we run 1, or to the right 1. 1, 2, 3, 1. 1, 2, 3, and right 1. 1, 2, 3, and right 1. 1, 2, 3. And you can go on for as long as you want. And then this, remember, up 3 and right 1, similarly is the same as down 3 and left 1, because I have to make a straight line here. Down 3 and left 1, down 3 and left 1. You can go on forever if you want, or I'll just stop at the end of my grid. Okay, so now we have some points along the boundary line. And now we have to look at the inequality symbol. Well, I noticed that this is a less than, but it also has the equal sign, less than or equal to. So as soon as you see that equals piece, we know that this is going to be a solid boundary line, which means that the points, every single point along this line, not just the points we graph, but all the points in between, which make up that line, are part of the solution set. So this one has a solid boundary line. Those points are included in the solution set of this inequality. And we'll put our arrows here for good measure. And let's go ahead and label it for good measure. So y is less than, I'm using the original one, which we didn't change, 3x minus 2. Okay, now again, this question of which way do we shade? And this is going to give us, the answer. Well, you're probably thinking, hey, go ahead and just stop, because I can see that answer choice number 1 cannot be right because this guy has a dashed line. So you could probably say, all right, answer choice 1, answer choice 2 is correct. And that would be correct. So we can actually stop there because we've eliminated this one. But I want to give this one a thorough look. So just as a review of which way we shade, again, we are looking up above. We're considering all the points above the purple boundary line as either the solution set of that inequality, or we're looking at all the points below it. And so we have to decide. And again, we'll use the test point. I'll use green here, 0, 0, because if you notice 0, 0 is not on the boundary line, so it's a good one to use. So we're going to plug 0 in for y, 0 in for x, and we plug 0 in for y, we get 0 is less than or equal to, 3 times 0 is 0, and a minus 2. 0 minus 2 is -2, so we have this inequality, 0 is less than -2. And so we have to consider that. Is that true? Is 0 less than or equal to -2? It's definitely not equal to -2, but is it less than -2? Well, no. 0 is not less than -2. -2 is less than 0. And if if you've forgotten, graph a number line real quick. Here's 0, here's +1 and +2. Here's -1 and here's -2. If you think about which one's less, well, the one to the left is less, and -2 is to the left of 0. So -2 is less than 0, not the other way around. 0 is not less than -2. So similarly, this is not true. And so 0, 0 is not a solution to this inequality either, or to this inequality. And so what that means is 0, 0 is not included, which means we need to shade the other side that doesn't include 0, 0. And I'll do that one in orange. And so again, we could sit here all day and plot every single point, or as close to it as we can in one day, or we can just use the shortcut and just use our shading, this idea of shading here, or representing all points. Okay, so the orange represents the solution set of this inequality, and the pink represents the solution set of this inequality. And when we're talking about the solution of the set of inequalities or a system of inequalities, we have to consider where the two regions overlap. So we basically have to look for where there's orange and pink at the same time, and that's here. If you notice up in this section here, this represents the solution set of our set of inequalities. So this guy here is our solution set. So all the points up here satisfy both inequalities at the same time. And sometimes you'll see a big S here, but we don't in this case. And sure enough, this answer matches answer choice 2, which we already found out earlier by process of elimination. But now that's the complete explanation, and the answer to this problem is 2. Which value of x satisfies the equation 7/3 times the quantity x plus 9/28 equals 20? And then there are 4 answer choices. So what is this question asking us to find? Well, we see this phrase, which value of x satisfies the equation. So really all that's saying is, what is the solution? When we're looking for a value that satisfies an equation, we're really looking for a solution to the equation. So we have to solve this equation for x. So let's go ahead, and there's a few ways to do this. We'll look at some different approaches, and you pick the one that works best for you. So we have 7/3 times the quantity x plus 9/28 is equal to 20. So we'll call this method 1. So the first way you could approach it is by seeing that there is a fraction out in front of a quantity here, in front of parentheses, and getting rid of this fraction. And the one way to get rid of the fraction is by multiplying both sides by the reciprocal of that fraction. So we multiply each side by 3/7, and it's nice to put the 20 over a 1, so we have 2 fractions. And then we can say, well, 3 times 7 is 21. 7 times 3 is 21, which that's going to be 1, and that will get rid of the fraction. And x plus 9/28 is equal to, and then on this side here, we have 20 times 3, which is 60, divided by 1 times 7, which is 7. And this won't simplify, but that's okay. So 21/21 is just 1. X plus 9/28 is equal to 60/7. And we'll leave this because this doesn't do anything. We can't simplify that any further. And when we ever have 1 in front of a group of parentheses, we can just distribute the 1 through, which in effect allows us to drop the parentheses in a way. So we have x plus 9/28 is equal to 60/7. And at this point, we have x plus some constant is equal to another constant. And in order to solve for x, we can subtract that constant from both sides of the equation. And that will remove that and give us 0. So we'll have x plus 0, or just x, is equal to 60/7 minus 9/28. And now we have some fraction fun, so we need to be able to simplify this. So we can do so by finding a common denominator, and I know that 7 and 28 have a common denominator of 28. That will work. So we can multiply this guy by 4/4. Oops. 240/28 minus 9/28, which gives us 231/28. All right, so there we go. And we can try to simplify that if we want, but if we look at our answer choices, since this is a multiple choice, we can see that the answers are given to us in decimal form, and this is in fraction form. And the easiest way to do that is to convert our fraction to a decimal. So let's pull up our trusty calculator, and let's go ahead and enter 231 and divide that by 28, and we'll get 8.25. And we can see right away that our answer is going to be answer choice number 1. But as you may have learned, it's always good to just check your answer. So if we got 8.25 and we want to make sure that 8.25 satisfies this equation, we can use our good habit of checking by substituting 8.25 in for x and seeing if this side of the equation, when we evaluate this side of the equation with x is 8.25, is equal to 20. So let's just do a quick check, just for good measure to make sure our answer choice is correct. So we'll just substitute 8.25 in for x. We want to see. Notice I'm not solving this equation because I simply want to take this value here, the left side of this equation, and type it in. I'm going to just type it into a calculator and make sure it equals 20, because that will guarantee that we have the correct answer. So how can we type this all in? Well, let's do 7 divided by 3. And I see parentheses, 8.25 plus 9 over 28. And I'm going to close my parentheses. I'm going to hit enter, and I want the value to be 20. And it is. So this checks out. Our answer is correct. Okay? So if you're satisfied with that, you can stop the video. But there is another way that you could approach this. There are lots of different ways you could approach this. But we'll look at just a couple. Here's another method, and it gets us to the same answer. So let's just take a look here at 7/3 times x plus 9 over 28 is equal to 20. So you may have learned, or you may have thought to yourself in method 1, hey, I always thought that you distribute first. Well, you don't have to distribute first. As we saw in method 1, you can get rid of the fraction first. But if you do want to distribute first, you can do that. So if you want to get rid of the parentheses by distributing the 7/3, you can distribute the 7/3 through the binomial and get 7/3 x plus 7/3 times 9 over 28 is 7 times 9 is 63 over 3 times 28, which is 84, I think, I hope, is equal to 20. And at this point, this just becomes, another equation with fractions and stuff like that. So we can get rid of our constant by subtracting 63/84 from both sides of the equation, which will give us 0 on this side. We'll just cross it out. We have 7/3 x is equal to, oh boy, I don't even want to deal with this. I got to get this over 84. What a mess. So I'm just going to leave it written like this, because I know at the end of the day, I need a decimal. So I'm just going to not do this as a fraction because I can just type it into a calculator and get a decimal. And actually, why don't we just do that now? So we know 7/3 x is equal to, and you could, of course, get this over 84. You could times that by 84, get a huge number, get this ugly fraction. And that's, of course, fine. But since we are headed for a decimal, we'll go ahead and just simplify this a little bit by opening up our calculator. Oops, let's see what we're looking at. So we want to figure out what 20 minus 63/84 is equal to. 19.25. All right, that is much nicer. I'm just going to leave it like that. All right. And now at this point, we can multiply by 3/7, or we can multiply by 3 and then divide by 7. Would give you the same answer. So let's just do a quick multiplication by the reciprocal. And that, of course, becomes 1 because it's 21 over 21. Gets us to the exact same point over here. So we just have like 1x is equal to whatever this is. 19.25 times 3/7. So let's do that. 19.25 times 3/7. And we get 8.25. That's nice. Oops. That is not intended to be a decimal there. So where's that? So we have 1x is equal to 8.25, which is, of course, x equals 8.25, which is the exact same answer we got in the other method. So those are just two methods to solve this equation, and there's lots of different ways you could really do this equation. You could start by changing all the fractions to decimals first, and then distributing, or you could turn everything to decimal and then divide out the first decimal out in front of the parentheses. Really, it's up to you what you want to do first, but these are two very, more, I guess you could say, popular approaches. Getting rid of the fraction because that makes it usually a little bit easier to work with, or distributing to get rid of the parentheses first. So those are two common ways to start an equation like this, but again, you can start it really however you want. All right, so we just saw two methods that involve solving the equation by hand. So we'll look at two more methods that both involve the use of technology, your graphing calculator, to help you answer this question. So we'll look at something that we'll just call method 3. And this is a technology-based solution method. So with this method, what we do is we look at our equation and we see, there's the left side of the equation and there's the right side of the equation. And we look at each of these sides as two different functions. So we'll think of this one as, just some function of x, and we'll think of this as some function of x. We'll call it f of x, g of x. It doesn't really matter. The idea is that this is some function, this is some function. And what we're trying to do is see where these two functions are equal. Now, if you recall with your graphing calculator, we can graph functions. So what we're going to do in order to find the x value, essentially where f of x is equal to g of x, which would be the solution to this equation, we're going to use our calculator here. And this is kind of neat. I'll bring it up and we're going to say, well, to find where two functions are equal, well, we could graph the two functions and find where they intersect. That's essentially the same thing. So what we'll do is we're going to go to our graphing calculator. We're going to go to y equals to our grapher. And for y1, or f of x, our first function, we're going to type the left side of the equation. So we'll do 7/3 parentheses x, which is this button here, plus 9 divided by 28. Close our parentheses. And this is y1. So we're essentially setting the first function in our graphing calculator to the left side of the equation, which we're going to call f of x. And then in y2, we're going to set that to the right side of the equation, which we're going to call g of x, or y2. And we'll just type in 20, because that's all that is on that side. So if you look here, you might be thinking, well, if I graph this is going to be a line with some slope, 7/3, and this is also going to be a line with a slope of 0, or just a horizontal line. So we expect to see two lines on our graph, and so we'll graph those. And now what we'll do is, now that we have the two functions, we'll hit the graph button. Remember, the purpose here is to find where those two graphs intersect. And so it graphs, and here's our standard window, and you might think, well, I only see one graph, where's the other? Well, if you think about it, y equals 20, or that's going to be, this only goes up to 10, so your horizontal line somewhere up here where you can't see it. So we're going to go to zoom, and we're going to go down to option 0, which is zoom fit. So hit the down button until we get to number 0. There we go, and hit enter. And this will zoom out a little bit and put the graphs so you can see them together. Okay, there we go. So there's the left side of our equation, this guy, so this function essentially. And then there's this guy here, the right side of our equation, or what we were calling g of x, or y2. And what we can do is, in order to find the solution to this equation, we can find the x value at which these two functions, or the left side and the y side, are the same, where they meet. And that's this guy right here. So here's the point of intersection. If we can just figure out what x value is down here, there's our solution. And, well, your graphing calculator will do that really nicely. So we're going to calculate. So see this, here's the calculate menu. So we want to access the calculate menu, which is the blue. So we're going to hit second and then trace to go to our calculate menu. And we're going to calculate the intersection, number 5. So you can either hit the number 5 or just scroll down to number 5 and hit intersect. Now at this point, it's going to say first curve, just hit enter once, hit enter twice, and hit enter again. And it will calculate the point of intersection. It puts the cursor right there. You can see it. And if you look here, the intersection is x equals 8.25 and y equals 20. So it's the point of intersection, but essentially the x value that makes these two functions the same is at 8.25. And sure enough, there is our answer. There's our solution. So that's one way. That's a technology way to allow us to do this, thinking, like, using the idea that each of these two sides can be seen as two different functions that we're looking to see whether they're the same, or the x value that makes them the same. All right, and method number 4, which we're also going to call a check method. But this is your cheap method, and this one only works when you have multiple choice. And this method is basically just the substitute and check method. All right, and is what it basically says is the substitute and check method is really where you're just going to take each of the 4 answer choices and substitute them in for x to see which one satisfies the equation. So let me erase this really quick. And so just to show this method once more, we already saw it actually when we did it this way. This idea of checking, where you substitute the answer that you got in to see if it satisfies, is really all we're doing here. But instead of actually solving the equation all the way through, we start from our answer choices and just plug each one in to see which one satisfies the equation. That's why we call this a cheat method, because you don't actually have to do much, but it does get you the answer, especially if you're in a rush to finish the test or whatever. This is a quick way to get it done. And so the way that you would do this is by substituting each answer choice in just one at a time. And so we'll start with our first one, pretending that you didn't know that 1 was the answer. You just start at the beginning and go through. So we could do 7/3 parentheses x, and instead of x, we're substituting our first possible solution, plus 9/28, and then close parentheses, and we're going to hit enter to see if it equals 20, and if it does, it's the answer, and it does. So number 1 is the answer. We have confirmed using method 4 what we already know to be the case. But for the sake of illustration, if say when you hit enter, this wasn't 20, if it was something else, then that would mean this was not the solution, and you would move to the next one. And so we would then test the next one, 7/3 parentheses, and then 8.89 substituted in for x instead, plus 9/28. And we'd see right away that this does not equal 20, and therefore we could say this is not the solution because it does not satisfy this equation. It does not make it true. And similarly, you could do it again for the third one. I mean, at this point, it's not necessary, but you can see the purpose where you would just go through each one and just quick type them in and see which one gives you, oops, that didn't work out right, to see which one gives you the 20. And so again, this is not 20, this is not a solution. And 44.92 would, again, produce something that's not 20. And so by using method 4, which is the cheat method, that's why I saved it for last, because the other ones are so much better. But it gets you the answer. And again, it only works for multiple choice. If this were not a multiple choice and this were a short answer question, you would have to go through and choose one of these other methods here. Okay, so in summary, we looked at 4 different methods to answer this question about which value of x satisfies this equation. In other words, what's the solution? We saw 2 methods that were manual, essentially, and you actually did all the steps to solve the equation. The first one involved getting rid of the fraction first out in the front, and then managing the parentheses and working with your fractions. And method 2 involved getting rid of the parentheses first, and then managing the fractions. And again, we said that you're not limited to just these 2. You also could get rid of the fractions and convert these fractions to decimals first, and then distribute or whatever. There's a lot of different ways you could do it. You could multiply by 3 on both sides, then divide by 7 as 2 different steps. Lots of ways you could have approached this. But these are the 2, I guess you could say, more popular methods, more direct methods to get to the solution. And then we saw 2 tech-based methods with your graphing calculator. Method 3 involved looking at each side of the equation as a separate function, graphing each of those functions as y1, y2, and finding where they intersect, or finding the x value where they intersect. And that x value is the solution to this equation. And then method 4, which is the cheat method, and it only works for multiple choice, but it's just to plug each one in, to brute force, see which one works, and you get the answer that way as well.